Example 2. Given that y is equal to 6x squared plus 2, find y over dx from the first principle. So we do the same, write the formula. So the formula is given by dy over dx is equal to limit as h approaches 0 fx plus h minus f of x divided by h. So this is our formula for the first principle. Then we start substituting. We're going to say dy over dx is equal to limit as h approaches 0 f standing for the coefficient, which is 6. Then the function x squared, this is where we put x plus h to the power of 2 plus 2, even you say plus 2, minus f of x. So f of x is this function here, which is 6x squared plus 2. So minus 6x squared plus 2 divided by h. So from here we can easily now expand. So I want you to pay attention to x plus h squared. I think you can expand this one separately. You can even do it from here. We have x plus h squared, which means that this is x plus h and another x plus h. So when you multiply x and x, the answer will be x squared. When you multiply x and h, the answer will be hx. You come to this one. H multiplied by x, you get hx. H multiplied by h, you get h squared. Now these two are like terms, meaning the coefficient here is 1 and here the coefficient is 1. So it will be 1 plus 1 giving us 2hx. So the expansion of this x plus h squared will be, let me write from here. It will be dy over dx is equal to limit as h approaches 0, 6. So the expansion will be x squared plus 2hx plus h squared plus 2. Then you come back here and multiply. When you multiply these two, you get negative 6x squared, and this will give you negative 2. So we say minus 6x squared minus 2 divided by h. So you can easily now multiply 6 by everything that is there in the brackets. So dy over dx will be equal to limit as h approaches 0. So you have 6 by this one, you get 6x squared, 12hx, you get 6h squared plus 2 minus 6x squared minus 2, and everything divided by h. From here you can now correct the like terms. So you have 6x squared minus 6x squared, and you also have positive 2 minus 2. All these will give you zeros. So from here you can say dy over dx will be equal to limit as h approaches 0, then we are remaining with 12hx plus 6h squared over h. 6x squared minus 6x squared, the answer is 0. 2 minus 2, the answer is 2. No wonder we haven't written them. So we can continue by saying dy over dx is equal to limit as h approaches 0, then we have 12hx plus 6h squared. I think we can factorize this one, but our main interest is on the h part. So we factorize by saying h into 12hx, we are going to remain with 12x. Then h into 6h squared, here there are 2, so when you remove 1, you remain with 1. So it will be 6h, and everything divided by h. So we can easily say, oh, this one into this one, we are reducing this one into this one, 1. So we remain with dy over dx is equal to limit as h approaches 0, 12x plus 6h. Here we are saying h approaches 0, meaning in this function, where you see h, the part should be replaced with 0. So it will be dy over dx is equal to, so this time you are not going to say limit, no, you remove it. You just substitute, you say, oh, 12x, and where there is h, I put 0, because I'm saying limit as h approaches what? 0. So this will be dy over dx is equal to 12x plus 0. So the final answer is simply what? 12x. This is our dy over dx. This is our gradient function. When we say gradient function, for example, if the question was saying find the gradient at a point where x is equal to 1, this is our gradient function. So if I wanted to find the gradient, it is just a matter of substituting 1 here, and the answer will be 12 multiplied by 1, which is 12. But the question was just asking you to find the derivative of the gradient function. So this is our final answer, 12x.